Hello class. So I'm going to make a couple of videos on some practice problems for the three types of problems you guys are going to see on your first quiz for Chapter 7. Our first one, we're going to work on converting moles into atoms. So the question just asked, convert 8.1 moles into atoms. Our first step for unit conversions is to identify the unit we want and the unit we have. So the unit we have is the unit that our original value is given in. So we have 8.1 moles. That's the unit we have. And we want to convert it into atoms. That's the unit we want. So we've identified we want atoms, we have moles. Our next step, we need to write the equality that relates these two units. There's an equality between two units that shows how they can be converted. For moles and atoms, this is one we've learned. We know that 1 mole is equal to 6.02 times 10 to the 23rd power of atoms. These equations are equal because we know 1 mole has 6.02 times 10 to the 23 atoms. We have this equality between our two units from our problem, and we're good with that step. The next step we need to do, we need to make a conversion factor. We need to make an equal fraction that relates one side of this equation to the other side. So our rule for doing that is to put the unit we want, which is atoms, over the unit we have, which is moles. We were given something in moles, so that's the unit we have. We want to turn it into atoms, that's the unit we want. So I put the atoms on top. First, let me write, it's the unit we want over the unit we have. For this equality, that would be 6.02 times 10 to the 23 atoms over 1 mole. We don't want to put 8.1 moles in right here because being a conversion factor, the top and the bottom have to be equal to each other. That's what makes this a conversion factor. It makes it equal to 1. We can multiply this conversion factor with anything. We don't change the value, we just get a change in units. So that's why we write out this equality statement to say we have this side is equal to this side. And if we put something equal over what it's equal to, we get 1. So now that we've built our conversion factor, we now bring in our original amount, the amount from our problem, our 8.1 moles, and multiply it by our conversion factor. So we'll bring our conversion factor down, multiply it by 6.02 times 10 to the 23 atoms over 1 mole. And here the magic happens. We can say, or what we can do is, because we've got moles on top, and I'll draw it over 1. We can put anything over 1. It does not change the value of it. We've got moles on top, and we've got moles on bottom. We can cancel them out. Because we have a unit on top and a unit on bottom, we can take 1 off the top and 1 off the bottom. That's got to be done in pairs. You can't just take 1 off the top without taking 1 off the bottom, and vice versa. So now we've got 8.1 without any units times 6.02 times 10 to the 23 atoms, all over a 1 on the bottom times a 1 on the bottom without any units. So everything's over 1. This is just straight multiplication across the top. Gives us 8.1 times 6.02 times 10 to the 23 atoms. Now, this kind of goes back to our second problem that we're going to do. When we're multiplying with scientific notation, just worry about the coefficient part of the scientific notation. Take the base and the exponent along for the ride. Don't change anything. We'll adjust everything after the fact. So if we get out our calculators and we do 8.1 times 6.02, 8.1 times 6.02, we end up with 48.76 times 10 to the 23 atoms. This is the correct value for how many atoms we have, but it is not in correct scientific notation. Remember, correct scientific notation only has one digit to the left of the decimal. Here, we've got 2 digits to the left of the decimal. So as we talked about in class, what we want to do is we want to move this decimal over to its proper spot. We want to move it over to only have one digit to the left, and we'll rewrite this as 4.87. We'll drop this 6. If you want to round that up to 4.88, that's fine. I won't be a stickler about that. But now we have times 10, and our exponent now becomes 10 to the 24th atoms. Because it becomes 10 to the 24 because as we move our decimal to the left, we have more distance. We add one more space that it has to go to get back to its original form. Remember, this 4.876 times 10 to the 23, when its decimal was right here, it was actually, its true place was 23 decimal spots all over to the right. So if we move this decimal over to the left one, it now has to go 24 spots over to the right to get to where it actually is, to get to where it is written in long form. So since it has to go 24 spots now, that the exponent on our base 10 becomes 24. And that is our final answer. That is how many atoms are in 8.1 moles. 4.87 times 10 to the 24th.